Next session, we would like to welcome Tejasvi Sedimbi. Tejasvi is working as a senior associate at Cognizant, and he would be speaking on the topic performance testing terminal based applications using open source tools. To know more about him and to see his video interview, please check the link given below. Uh, Hello, sir. Hello, Tejasvi, sir. Are you there?
Hi, Alankrit. Yeah, I am there.
Okay. Sir, I'll stop sharing and you can continue.
Yeah, sure.
Thank you, sir.
Hi, all. Are you able to see my screen?
Yes, we can see your screen.
Hi, all. This is Tejasvi. I'm here to talk about performance testing terminal applications using open source tools. So I'll start with some history of terminals and proceed with the use cases for terminal applications and need for performance testing and challenges facing performance testing them, and end my session by giving a overview on open source tool, using open source tool for performance testing them, and what are the key elements in the open source tool to use. So let's begin. History of terminals. So in the initial days during 1960s, when the terminals were introduced, they are dumb and they're more like just a peripheral devices attached to the main computers, and they couldn't do any real processing of the inputs by themselves. And the main computer has to respond to each keystroke. By 1980s, they are able to process and send blocks of user inputs like a field by field or form level. And with the advancements in microprocessors and lower memory cards, they are able to support local editing operations such as editing fields or editing form level. So in later days, it was also became possible to load several personalities into a single terminal. Like one vendor terminal can be used to emulate the other vendor terminals as well. And in the next days, we got terminal emulators being developed for many terminals. And nowadays, we have terminal emulators being developed for all the terminals in use. And we are using Windows terminal, Linux terminal, and Cloud Shell in our day-to-day activities as an essential tool. So this is how the terminals have transformed over the years, and now we are using them very much in our day-to-day activities. And we are even using terminal emulators in a wide in every area like testing and even for development. Sometimes we are depending on terminal emulators. So now comes the use cases of terminal applications. Let's start with what are the terminal based applications. Like when I say terminal based applications or terminal applications, they are like where the presentation layer or the end user interface is presented via terminal, and the backend can be written in Java, .NET, or any other programming language. But the interaction from the end users can be done only via keyboard operations, and there won't be any graphical user interface, and you can't use mouse to do any operations on it. And a terminal emulator is a software which is developed to emulate a terminal window within your computer. You can have multiple terminal sessions running within the same PC using a remote terminal emulation protocol. So terminal emulators are used to interact with servers such as AS400, IBM i systems, Jet systems, and many other mid-range and mainframe systems. So mainly in real world scenarios like mainframe systems, interacting with mainframe systems using RFID devices in warehouses, retail stores, distribution centers can be emulated and tested by using terminal emulators. So below shown screens are sample screens from a terminal application, which is used in a warehouse distribution center, where the warehouse operators enter the product details like SKU and the pre-advice ID to receive the stock into the warehouse. Then they once they give the SKU and pre-advice ID and give enter, then the further screen appears where they give the quantity of the product and the tag to which they want to tag the receiving product and the location where they want to receive, and proceed further. Then they confirm the location, receiving location, and once they continue, the receiving gets completed and the stock gets updated in the warehouse management system. So screens like this and the mainframe system screens can be tested by using terminal emulators software. To test them, we need to know the terminal type. like is it a VT terminal, is it a IBM terminal, or is it a ANSI terminal, or is it a ASCII terminal, etc. And the communication protocol which is being used for the communication between the terminal and the application server. It can be SSH or Telnet, etc. So we need to know the terminal type and communication protocol to be used for the application under test, so that we can emulate the application flow correctly. And now coming to the need for performance testing, we need to test the terminal applications to ensure they are up to speed, they are stable, and they are scalable when high concurrent user load is accessing the terminal applications. So we need to do the performance testing to make sure that terminal application is responsive when multiple concurrent users are accessing the same flows, and to ensure that the terminal application is able to run all the foreground and background process under daily usage conditions and under peak usage conditions, while returning the valid responses to the end users. And to make sure that application is able to handle expected volumes of transactions under daily usage conditions, which is average load, and under the peak day usage conditions, which is a huge peakest maximum amount of load received. And to confirm that the response times for the critical business transaction steps, like suppose in the previous screen, where this is the critical business step where the actual storing the stock in the warehouse happens, and the system gets updated with the stock details. So such kind of critical business transaction steps, response times are within SLA, to ensure that we need to test with the daily usage load and peak day usage load, and to make and we can confirm that the response times of the terminal flow steps are performing within the SLA. And to ensure that the stability of the application and server infrastructure is valid and it is stable under prolonged usage conditions. Under prolonged usage conditions, suppose if the code is having any memory leaks, then it can cause disruption to the application. The application can become unstable, and it can lead to the failures, and end users will be stuck in their screen, or end users may get exceptions or the errors in the screens. So to avoid that, we need to test for the prolonged usage conditions to ensure stability and server of this application server infrastructure, and to make sure that the application infrastructure can be scaled up easily to support increasing user base and increasing transaction volumes. We need to do the scalability testing as well. And to make sure that the application is able to handle expected volumes of transactions from inbound flows and outbound flows to external systems, connected to external systems, we need to test the interfaces as well in parallel to the terminal flows running through the application. Now let's see the common challenges faced in performance testing terminal-based applications. Traditionally, performance testing terminal applications was only possible through legacy commercial tools like LoadRunner and Silk Performer until 2018. With commercial licensed tools, we need to buy the license for the required number of to emulate the required number of virtual users. So it would be an additional cost. So if for a 400 virtual users of LoadRunner license for 3 months period, it costs around $20K US, which is huge. So we need to spend extra amount to test the application, which will be adding to the project budget. So this can be eliminated by using open source tools. And application knowledge. So because these are keyboard based application, we testers needs to be well versed in using only keyboard operations. Depending on the particular page, the attention keys, the function keys to be used will differ in the terminal flows. So testers need to be well versed in navigating the flows throughout the application, and they need to make a note of all the keys to be used so that they can easily develop the performance scripts to test the application correctly. So testers also need to be aware of the positive and negative scenarios responses coming from each scenario, so that they can develop automated test scripts to handle both positive case and negative case without manual intervention. And coming to scripting challenges, testers need to be able to incorporate text checks, which are common in our testing scenario.
Excuse me, sir. We just have a couple of more minutes as for the interest.
Yeah, okay. But testers also need to use cursor position checks in case of terminal flows, which is different from other application flows. Because we don't have implicit response codes in case of terminal flows, like HTTP response codes will not be there. So we need to use either text checks or cursor position checks. And we should also be able to customize the scripts to respond to prompts, errors, and navigate back and forth to avoid abruptly logging of the session or closing the terminal. So BlazeMeter introduced RTE plugin in July 2018, and for now, JMeter RTE plugin is currently supporting IBM mainframe protocols TN5250, TN3270, and VT420, which is used in warehouse distribution centers. And using this plugin, we can easily simulate the terminal-based application flows, like specify the position of fields on the screen and send the text to the screen fields, and simulate for filling forms or calling process, etc. And because JMeter is open source, we can save license cost money, and it is supported for both scripting and running tests in Mac, Linux, and Windows operating systems. And as it is built in Java, it supports a wide variety of error handling using Java constructs, and it supports string handling and file handling operations easily because of using Java, and it can support Java and JavaScript. And it can support simulating more number of virtual users compared to other licensed tools. And as it is already an open source tool, it can easily integrate with other open source tools like Jenkins and other DevOps tools as well. So these are the key elements of a JMeter RTE plugin, which will be used to simulate the terminal-based applications. So RTE config helps us to configure to the give the configuration properties of the application server to test. We give the IP address, we give the port to which to connect, protocol using, and SSL communication to be used. And RTE sampler supports 3 actions: connect, send keys, and disconnect. So connect just establishes the connection to the terminal against the specified using the specified configuration. Send keys supports sending values to the forms, like user perf1251 is the username, and the password is hidden just for the safety purposes. So we can send whatever the inputs we want, and these are the attention keys supported, like F9, enter, clear, reset. These kind of attention keys are supported, and we can simulate filling full forms and sending many fields and attention keys. And we can finally use the disconnect to close the terminal session. That's it.